Our talk is Smartfuzzing the Web. Anybody in here speak Latin or understand Latin or anything? So, does anybody want to take a guess at what the subtitle is? Sees your holes. Well, close enough. Close enough. So there was a lively debate when we were putting this together. Apparently, a lot more people speak Latin than I really knew about. So after days and days of deliberation, it was decided that this was the correct subtitle. A little bit about us. We work for Fishnet. My name is Nathan Hamill. I'm a principal consultant at Fishnet on the AppSec team. I'm also an associate professor of software engineering at UAT. Go ahead. I'm not introducing you.
I'm Justin Engler. I'm also with Fishnet, and I'm a security consultant with the application security team.
Justin's also known as J-Rock for anyone out there. I'm Seth Law. I'm also obviously with Fishnet Security. I'm one of the principal consultants, and yeah.
I'm Gregory Fleischer. I'm also with Fishnet, and I'm a senior security consultant, and I do application security assessment work.
So like he was saying, this is J-Rock. We went through one day and decided to give everybody on our team hip-hop names. So it was very entertaining. So an overview of what we're going to be talking about during the course of this presentation. So we have a few things that we want to cover. You know, none of this stuff is probably things that, you know, people who test on a daily basis don't already know. But some of these issues are things that don't get talked about a lot. Or we spend a lot of times as experienced testers, we spend a lot of time working around problems instead of solving them. So that's kind of what this is about. We're going to talk about problems with current tools in technology, current workarounds, things that people usually do to make things work when they don't work natively, some proposed solutions, and we're also going to talk about a tool we're releasing today called Raft. Did anybody come by and see a demo of Raft at the Arsenal? Anybody? So nobody was that interested? That's awesome. But the people who did bother to stop by gave us some pretty good feedback. So hopefully you like it, and hopefully you use it, and everything will be golden. So here's a couple of things that we aren't going to do. We're not going to beat up on any specific tool or vendor, although sometimes we're tempted. We're not going to do that. As of right now, all of the problems we discuss in this talk aren't solved by our tool, and some of them aren't necessarily technology issues, although a vast majority of them are. And we're also not going to sell you a solution. Obviously, the tool we're releasing is open source. You can go download it, play with it, hopefully submit bug reports, write code, all that good stuff.
And we also didn't want to just get up here and do a bunch of griping, and point out all the sky is falling and all the bad problems that are out there. So if you want to read about that stuff, read our white paper, because we put a lot of time into going through and saying, here's where like automated scanners completely are falling down, and here are some of the problems with it. So, we're not going to be able to solve all those problems here today, but we wanted to get that stuff out there because a lot of times, people have moved into roles in application testing who aren't necessarily application experts. Maybe they used to be on the network team, and now they've been tasked with scanning their web applications. So they choose an off-the-shelf point-and-click tool, get some vendor presentations, it looks good, and they run it, and it comes back and says, hey, everything's okay, there's no problems. And they think, okay, I'm secure, I'm doing good. So we just want to get up and point out some of those issues where there are some blind spots that you have, and we just want to lay it out there.
Yeah, and there's also a tendency to try to purchase problems away. And complex testing issues aren't something you can just purchase away. It takes a lot of time, effort, and resources to find complex vulnerabilities. So mainly our goals are to raise awareness for some of these issues, some of these more complex items, and to put focus back on the tester and, not tools so much. So tools should be there to help a tester identify vulnerabilities, not the other way around. And also to get you to submit bug reports for Raft, because that's where we need help. So a little bit of clarification here on some of the terminology we use, because it can kind of seem like we're using terms interchangeably. So two things here. automated testing and semi-automated testing. So automated testing would be your fully automated vulnerability scanner type tests. And how we kind of see that is that's like the Mac 10 on the right-hand side, right? It's not very accurate, and you have to get close, and you're spraying a ton of bullets and potentially hitting nothing. So semi-automated testing, which would be, creating a test case and then sending a bunch of data to that test case, is more like the semi-automatic sniper rifle with the scope on it. So you're narrowing down your problems, you're identifying a specific source case, and then you're running that case to completion. And we'll kind of use those terms interchangeably at times, so we're not trying to purposefully be confusing, we're just rambling.
Okay, so let's move into some of the problems, right? Y2K called, right? They want their tools back. Any of the tools that are out there nowadays that you go and you click the button and you say, scan my web application, they fall down in a number of different ways. I mean, we've got the modern technologies that are out there, most prominently the CSRF tokens or anything like that. A lot of them just don't understand how to submit a web form that contains a CSRF token that changes from request to request. Your other modern technologies, the web services, the rich internet applications, anything like that. We could beat up on any number of vendors or even open source projects that just don't understand what is going on with them. Again, I've got other stuff listed up here, but those are the main things that we're really trying to address. All these problems exist, and there's definitely a hole there. Each of us tests web applications on pretty much a daily basis, and this is what we see. These are the problems that we run into with modern web applications. MVC, anything like that is going to cause your automated scanner to fall down. More problems, right? Externally collected data, any data that, who here tests web applications for a living, right? Okay, cool. So we got a fair number of you in here. Right? You're using some intercepting proxy. You've got a whole bunch of data in this proxy. You've got a commercial scanner that you're using at the same time. Those two data sources, they don't connect, right? You're looking in your application scanner for specific vulnerabilities, in your proxy for others, and there's no good way to connect them both. It's a manual process for you to take that information, process those vulnerabilities, and then spit it into your report or to tell the client about it.
And that's if you don't even have to write a custom script to do a test. A lot of these applications that we're dealing with require custom tests, custom scripting, and you may have to generate tens of thousands of requests through this custom script, and unless you're storing it in a PCAP file on the network, and how do you deal with that data? So those are some of the issues that we've seen where we write these custom tests and we send all this data and we get those responses back, and that maybe we're looking for some very specific problem, and we're kind of blind to everything else that's going on.
Yeah, exactly. We're looking for these custom problems. We have all this data from our custom scripts, from our automated scanners, and from our proxy. We're not connecting those results, and then we're not running analysis on those results. I don't know how many times I've gone through a test and I've had to go back through and scan the application once again just because I forgot to check for something or something new has popped up. But I have all these results from previous spiders of the application that would be very useful if I were to analyze them in a smart manner. So, just because HTTP is stateless doesn't mean that our analysis needs to be stateless as well. With those automated scanners and with the semi-automated tools, a lot of times we're abstracting the results from the tester. The less that a tester understands about the application, the less they're going to actually be able to break it, right, and figure out where the problems exist. The more we understand about it, the better we're going to be at finding those SQL injection vulnerabilities or whatever it may be.
And if you think about commercial tools that are out there right now, there is more of a push out there from commercial vendors to put more abstraction in place and less interaction from a tester. That's really not the best way to find complex vulnerabilities. Experienced security testers need interaction and not abstraction.
Exactly. You think about the commercial scanners that exist out there. You give it a URL, you hit scan, you get a list of results. But if you don't understand what that application looks like from an architecture perspective or yeah, or from a, what it's using underneath the hood, you're not really going to be able to break that application. All right, so a couple more problems here. We miss hidden portions of the application. I've listed out, accept header manipulation or user agent manipulation. If you're coming from an iPhone, your user agent is different than if you're coming from the Firefox web browser. And the application may respond differently. It may push you to a separate portion of the application. So if you're only using the web browser that comes with your testing tool, you may be missing a whole portion or even half of the application that exists within that website.
And that's also like with web spiders. Often you'll see an application respond very differently if you say, oh, I'm Googlebot. I mean, people have been using that for years to access restricted portions of websites, but very rarely do we see testing tools incorporate that same type of logic. That's something very simple to do. Go through and re-request all the URLs in an application with a different user agent. Very simple, but yet we don't see it.
Yeah, we all know HTTP. It's really easy to change anything within that request. And, but a lot of times we don't do it when we're testing the application. The tool doesn't do it for us. Okay, more problems. Risk-based logins. You see these with a lot of financial applications nowadays. Depending on where you're coming from, it may ask you for additional forms of authentication to prove who you are. In addition, in-session detection may fall down. Right? In this case, down at the bottom, we've got an example from a test that we did where...
So, okay, first of all, does anybody know what the problem is here? Do anybody see why this might cause a problem with certain vulnerability scanners? Yeah. So the in-session detection is probably keying off a regex on sign out. So it's going to assume that it's still logged in and has a valid session, even though it's very clearly being asked to re-log in. So this is common with, online stores that allow you to, save data to a shopping cart or something like that, and then have to re-authenticate on confirmation of next step or payment details.
And I've also seen this on very highly templated sites. Like, let's say that there's a reseller of a product, and they'll have different skins, and they'll merge a couple of websites together, and you'll see those pop up when you switch between the two websites, like the checkout and the normal site. And the modern testing tools they just go bananas when they see that, because they can't figure out, oh, I'm not signed in. So they still run their tests. They think they're signed in, but nothing's working.
Yeah, and I mean, you see this a lot with, especially the open source and, some of the other scanners that exist out there, it doesn't realize that it's logged out, but it sends all those requests, and all you get is, log into the login page again, and, you've sent 2,000 requests with that response. Simple things that we miss. Request timings, right? There are ways to find denial of service vulnerabilities within web applications if we would just have simple information like the time it took for a request to complete. Maybe something is database intensive and it, takes 2 seconds to finish a request where everything else is going through in 5 or 10 milliseconds. These tools just don't tell us about that. Authorization checks, and client-side storage locations, those new technologies, the HTML5 locations, the LSO objects, and Flash objects, anything like that. We're not analyzing that. We're not trying to fuzz that in the current environment. Okay.
JRock.
So now that we've talked about all these different problems with the tools that you've got, you still at the end of the day have to finish your assessment. So you may end up using a bunch of different one-off tools that do certain things really well, and then you might also have to write your own tools to do, say, a slew of 5,000 requests against this particular set of URLs. But in the end, you end up with these results from all these different sources, and you don't have any way to combine them. So I've got all this response data, but now if I want to do an analysis on that, I have to do it all separately. I have to find some way to merge it all together. It's a pain. So there's a lot of other problems because you can't, the tools that are out there, they don't talk well with each other. They don't work well with each other. There's not really a lot of importing, exporting, all that stuff. Sometimes you'll have data, you'll have the same data that you made the same request from two different tools, but if they use slightly different things, like a different user agent, et cetera, you're not going to be able to easily spot the differences and spot the redundancies. So you need to be able to hook up all this data into one place and then run an analysis so that you can put it all together and get the same results out of all of it.
I mean, how many people save all the data for every request that they run? I mean, turning on the logs in their commercial tools, that's painful, right? I mean, I saw some hands raised. I mean, there's disk-based problems. I mean, they don't interleave data correctly. You have to go through and write custom tools to actually extract the data in a usable format. It's really painful. And you know, we're up here and we're trying to say, look, these are problems. And commercial tool vendors know there are problems, but yet they seem to do nothing about it. I mean, they rotate their log files. They do all sorts of nasty stuff that just make it nearly impossible to capture all the data. Because on numerous occasions, you know, we've done assessments, and like Seth was talking about, you have to go back, you find a problem, kind of like at the 12th hour, 11th hour, you find a problem, you have to go back, and if you had saved all that data, maybe you'd have a chance of finding it instead of having to rescan the entire site. I mean, that's not cheap. I mean, everybody says, oh yeah, network bandwidth is fairly inexpensive now, but time is not cheap. You know, there's only so much time, and you can save a lot of data to disk, and that sure beats having to retest an application.
It also gives you the ability to find new bugs in old data. So if you keep the data and you have a way of, you know, efficiently storing that data, then you can find new bugs without having to send data to the app again.
Even better when you found a bug from the results in tool A, now you want to see if it's in tools B, C, and D's results, because they all generated different stuff. You still need to get it all in one place. So we could try testing manually, but there's never any time to do that. Every assessment I've ever been on is time boxed. We usually get a couple weeks maybe, and there's just not time to do everything by hand when you've got a site that has 20,000 URLs on it, or, you know, 5 different sections of different applets, and it's just, you can't do it. There's no way. So then you could try writing your own scripts, but then again you have the problem of every single time you have to write a new script just custom made for this site, and then you have to find a way to analyze that data, and then you have to, it's just not a good use of the customer's time for us to continue to write the same scripts over and over again. So, and when you do that, you know, if I suspect that there's a SQL injection in this one thing, I'm going to write my script to try to track that down. But then it could turn out that there was XSS in there too, but if I didn't write that script, then I'm never going to see it. And because I'm not putting my results somewhere, then I'm never going to find it again later. So,
one of my favorite interview questions, which after I say this I'll never be able to ask it, when interviewing new candidates for our team, is I always throw it out there, you know, progressively getting harder questions, and then I say, you know, you're tasked to test an application, and you run into the application and realize that everything is random. So every single time, you know, the DOM lays out everything is random. That means the back button doesn't even work in the browser. Crazy stuff. How are you going to handle testing that when you know none of your current tools work? And the overwhelming majority of people say, I would test it manually, and the overwhelming majority of people fail that question. So the true answer is you either have to write something yourself or modify a current tool to do something for which it wasn't intended.
So yeah, we've seen people use Selenium and Windmill and those type of testing, you know, QA testing tools. I mean, this is a kind of a problem that QA testers have faced for years, and they seem to be getting to the point where they're solving it. You know, looking at highly randomized data and having, you know, the ability to replay directly into the web browser.
All right. So has anyone used Nick2 lately? Okay.
One guy.
See, yeah, 1, 2 hands. Dirbuster, anybody? Oh, okay, a couple more. All right.
Do you know when the last time those tools, well, yeah, that's like coming up, so that's fine.
So,
remember when we said we weren't going to bash any particular tool? Well, kind of, not sort of, really, a little bit.
Yeah, Nathan lied.
So there's Nick2 and Dirbuster both, but Nick2 especially, it looks like a scanner, right? But what it's really doing is they've just got this big long list of URLs, we try them all, and we see which ones show something, and then you report that as a problem. But when was that actually updated last?
It's updated about every year, But if you think about what it's doing, it's just basically sending a list of strings to your website and seeing if a very specific response comes back.
Yeah.
It doesn't do anything with any of the other information that was returned in that response. I mean, it could be missing significant issues.
It's almost like a blacklist virus scanner. You're going to find this one issue that somebody else has found before that's in this one exact format, and you're never going to find something that's just slightly altered from the norm. So,
and sometimes you'll see new open source tools come out, and they have this fancy GUI, and they have all these awesome features and everything. They can generate pie charts and graphs and widgets and all that. And then you find out under the skins, they're just using those old NICTU lists. That same logic that you thought was just failing miserably is being reused by this new open source project. Oh, Dirbuster, yeah. So what about Buster? Dirbuster, yeah. So how many people use the Dirbuster tool? I'll say tool first. Okay, there are people out there, excellent. How many people use the list from Dirbuster in another tool? Not seeing many people. So one of the things that people have started doing that we've encountered is they take those Dirbuster lists and they'll import them into something like Burp and run them through Intruder as a high efficiency way to find other problems. And those Dirbuster lists haven't been updated since 2007. And if you research how they were generated, they went out and they crawled a whole bunch of websites and they found a whole bunch of stuff. But if you think about the mechanism of doing that, they went out and they searched for stuff that they already knew about. And I mean, sure, there's some value in generating a very large word list. But if you think about how sites are constructed and how they're marketed and what type of effort goes into saying, here, come to my site, you'll start to find out that there's a lot of search engine optimization that gets applied so that you're finding things that are almost completely useless. So it just, on a normal assessment of in an enterprise application, you're not going to be finding a lot of Cialis directories. I mean, you're just not. And if you do, they have way bigger problems. They need to be doing some forensics on that box. So we want to kind of move past that. And we started looking at this, and we said, wow, there are a lot of common things that we see when we do assessments that just aren't in those word lists. And those are pretty much the only word lists that when we talk to people that they're using. So that was like, whoa, that's a really big red flag. So here are some of the common items that aren't in those Dirbuster small and medium lists. I mean, some of them are in the big list, but that's like over 1 million entries. I mean, has anybody ever seen the ASP.NET client directory on a web application? Anybody, Or how about those VTI directories, Those are on web applications that get deployed, and those contain very interesting information. So if you're kind of depending on Dirbuster lists to find those, you're kind of fooling yourself into thinking, yeah, I did a good job of scanning that website. So yeah, there's a lot of garbage in Dirbuster, and here's kind of our favorite example. I don't know if people know Jeremiah Grossman.
Yeah.
Some of you may have heard of him. Those are actual strings in the Dirbuster medium list. Jeremiah Grossman. I mean, do you think that's on a website out there? Maybe like one.
Maybe BlackHat. Of
Yeah.
course, we know that's on BlackHat, but
so it's like people don't stop and think about what these tools are doing and using as their data. There's a problem there, and we got to say, whoa. Hold on, there's got to be a better way to do it. And what was that, SVN Digger?
yeah.
Yeah, so their approach was to go out and look through SVN and CVS repositories and pull data out, is thinking that, okay, maybe this isn't data that we will see when we're crawling the web, because it's actually stuff that developers have written that wouldn't normally be exposed. And so that seemed like that had some promise. I don't know if people have looked at those lists. I think they could probably do some cleanup and better sorting, but those guys have some promise. And we said, well, what else out there do people say, don't look here, don't look here, don't look at this on my website? People familiar with the robots.txt standard? So robots.txt defines a disallow value. And we said, why not go out and kind of crowdsource the web and look for what people are saying not to look for on my website? Because those are like the directories that they don't want web spiders going into and saying, oh, well, I don't want this on Google, so let me disallow Googlebot. Don't want to see it. So we said, okay, let's actually use that information. We don't have to crawl the site. Most likely, there's directories that say, like, don't crawl here. There's probably a directory that exists there. So we went and took the Alexa and Quantcast top million sites. Those are very popular to use. Merged them together and came up with about 1.7 million websites out there. Went and downloaded, asked for a robots.txt file from each of them, HTTP and HTTPS when necessary, and we got about 1 million files back. And there was a lot of duplicates. There's a lot of WordPress out there, everybody, a lot of WordPress. And we came up with about 350,000 unique files. And from that, we generated some new word lists, and those are out on the website now. We'll talk about that later. But the one thing that I did go through and do, and this was kind of painful, was pick out some keywords that were basically keyword stuffing into robots.txt file by BlackHat SEO stuff. So there's some pharma and mortgage keywords that have been exposed. So like I said, if you have a Cialis directory or a Percocet directory on your website that you're testing, you're not going to see that.
So at the end of the day, one of the big things is to remember is that tools don't find vulnerabilities, people do. So our approach is to try to empower the tester to find these harder to find vulnerabilities and handle these new style web applications. So we decided to add to our tool something that we call a smart fuzzer. And when we started to design this, we thought about certain features that should exist in any modern semi-automated testing tool. That should be standard, that shouldn't be, shouldn't be optional, like it should be there. And a few of these things are session management without headaches. So one of the problems that people run into is when they design these tools, they don't really have tight integration of any of the components. So the components are usually in different places and they don't really have good communication between them. That's why you can't do certain things. That's why you're limited. So we thought one of the first things we would say is we wanted a shared cookie jar. So when you do your testing, you shouldn't have to say, okay, this is the cookie I want to track, this is the cookie I want to track, and everything else is just fine. So, kind of the approach would be to use a shared cookie jar. That way when you run a sequence or do something else, all of that data is immediately available to your test case. Proper in-state detection as well. So it should be able to detect when it's running into something and needs to re-authenticate or needs to resend the credentials back to the application. Another big thing is sequence running and building. So obviously a pre-sequence would be something like a login sequence, but you may need to run a cleanup sequence after you run your test case. So for instance, maybe you're testing a difficult application, one of those highly randomized applications, you might need to then run a logout sequence after you run your test case. And there's really not much out there to help you do that. There may also be multi-stepped operations, so you might need to do one thing, then another thing, then another thing, and then run your test. One of the biggest things about that is we keep going back to randomized data and CSRF tokens, right? Because a lot of people don't realize when they're testing these applications and they're using a tool and they send it to the semi-automated portion to run some of their own tests, they don't realize that all of the tests they're sending may be invalid because that token isn't valid anymore. So every single one of these tools should have the ability for you to be able to tag where the token value is and then put it inside of your payload and send it onto the application.
Yeah, so let's say that your CSRF token, protecting against CSRF, is based off your session object. And let's say they just do something simple like take an MD5 of the session object and stick it in as their token. Well, you run your test, you collect all your values, and you go back and you want to test again later. Well, you get logged out and you get a new session. And all of those tokens in your previous request data are no longer valid. And if your tool's not paying attention, it's going to think, oh, I'm just getting back some responses that just look like the normal form, but there's no action being taken on the back end. The application's detecting, oh, this looks like a CSRF attack because this token's not valid. Well, I'll just send back the same form that you had before, if that's how it's implemented in the application. If you're lucky, it sends you to the logout, and maybe you get a chance to catch that early on in your test. Oh, yeah, so another thing that we really felt strongly about is content discovery. These new modern web applications, you've gotten to the point where it's like the bad old days again. I mean, if people remember testing web applications before there were fairly decent spiders out there, it was extremely painful to have to walk through the whole application, click on every link, do all that stuff. But we're seeing now with, especially commercial tools, a lot of open source tools, you have to walk through nearly the entire application for it to develop an understanding of it. And that's ridiculous, because those links that are generated through DOM-based construction, pulled out of data sets through AJAX, you have a browser there that's doing that work for you. You're just having to drive it. Why don't you flip that around and have your tool drive the browser? Shouldn't you be able to do that? Looking at more intelligent form submission, that was a big thing that we felt really was lacking. Being able to go back and record a sequence of requests, and then go back and flip what the form values that could get submitted in there is. Let's say you want to test one account number and then go back and replay that and test a different account number without having to manually go through that. And that's just a very painful operation in a lot of cases. And looking at better content discovery based on contextual information. We talked earlier about how spidering using different user agents can reveal hidden portions, or sending different accept headers. That's very powerful, but you have to do that a lot of times as a manual effort, or to go through and customize your tool and send those requests specifically. In HTML5, I don't know where a lot of commercial tools that their heads are at with this stuff, but they're not picking up on it as best I can tell. In open source, I think it's completely missed the boat on it in a lot of cases as well. So we have these rich internet applications, and those are pretty much unmined for vulnerabilities. Just even looking at the web traffic is sometimes an extremely difficult exercise. Looking at AMF traffic and figuring out ways to get in there and test those values. I mean, there's not a fuzzer out there really that can handle AMF in any sort of strong and powerful way.
This is kind of you too.
Oh yeah, so this is kind of talking about the randomized data, and in a lot of tools kind of approach this as, well, we'll use regular expressions. The old saying that goes, if you have a problem and you think the answer is to use regular expressions, well, now you have two problems. So a better approach is to look at, let's just pull this data directly out of the DOM, right out of the DOM, and that kind of leads you down one of two paths. You can either develop your tools as browser extensions, which means then you have something you have to inject into your browser, which has its own set of problems, or you can build a tool that includes a web browser in it. Directly inside your tool is a web browser, and you use that to go through and capture any DOM information that's available, store that, and replay it in later requests.
And of course, any tool solution should have the ability for a tester to easily experiment with new features. So it should be fairly ergonomic to be able to go through and experiment with any new features to identify new vulnerabilities. So you guys ready to see what we've been working on now? We kind of laid out the problems. Ready to see the good stuff? Okay.
Yeah.
So
this was like the boring part of the presentation, but we have to be up here and give you some background and lay some groundwork. Otherwise, the rest of this stuff is not going to make any sense.
Yep.
It can't all be exciting.
Yeah.
Yeah.
Well, speak for yourself. We created this tool called RAFT, and it stands for Response Analysis and Further Testing. And this tool, like many tools, was born out of necessity. At first, it was a very simple necessity. Doing a lot of custom testing, I got tired of having to try to analyze all the data I was collecting. So I basically said it would be really nice to have a way to visually look at the data I've collected with my tools and scripts. And that's kind of how it started. Of course, it's nothing like the simple beginnings, but it basically had a few different widgets and allowed you to collect data and see that data, syntax highlighted.
Yeah, it was basically a SQLite browser initially.
So and that's part of the problem, because when you talk to people who who do tests and who write custom tests, some of the answers that I've heard from, well, what do you do with the data after you get it back, is pretty crazy. Because they would say they would put it in SQLite format and then use SQLite browser, which is only one step above being a sadist. Because there's no analysis, there's no way to properly view that data. You'd have to then write other tools to go and mine that data. So that's kind of how it started. And we have a few demos here. So this is you, J-Rock.
So RAFT stands for Response Analysis and Further Testing. That F can actually do a few other things too. We'll get to that later. So what's the biggest difference between RAFT and most of the other tools that are kind of targeted at the same area is that we're not an inspection proxy at all. We just left that out. So we're kind of giving you a different paradigm for how to finish your work and how to both get data into the tool and do things to the data you already have, add new data from the tool, etc. We've been working on RAFT since early this year.
Yeah.
Early this year, and
one of the big things it does, even if you didn't use any of the other testing tools, like day one, you'd be able to go back and get analysis for other tools you have in scripts. I mean, even just that piece, without using any of the other tools we have implemented, is a huge win for you when you go back and start having to do an assessment on Monday morning.
That's assuming you're saving your data.
That's assuming.
And it's all open source, Python 2.7-ish?
We'll
get to that in a minute.
Yeah, 2.6.5 and above.
Python and Qt. This is a tool that's intended for people that already know how to test websites. This is not the fire and forget app scan type, click it and it just tells you what to do. This is really intended for somebody who already has done this before, just needs some help with some of the things there aren't good tools for. We understand the output from a lot of different tools. We can import RAFT data of several different types because we are RAFT. We can import burp data of several different types. We can import paros.
Yeah, log data and conversation data.
And we've also got our own format, so if you're not using any of those, you can usually convert it to XML and then we can pick it up. We don't have an inspection proxy for you to use to get that stuff.
Did we mention it's not an inspection proxy?
Yeah.
That was like when we did our Arsenal, spent our time out there at the Arsenal, that was like the #1 thing people said is like, is this an inspection proxy? And we're like, no, it has a web browser built in. You don't need an inspection proxy. We're capturing all the traffic from your web browser.
And that like throws people for a loop for some reason. It's like there is absolutely no other way to get data in anything without an inspection proxy. You guys are losing your minds.
I know that when I use burp and when I use AppScan or things like that, their built-in browser is the last thing I want to use because it seems like it's really slow. It doesn't really support things well. We just pulled WebKit straight in. So if it works in Safari, it works in Chrome, it's going to work right here in Raft. We've also got a couple different fuzzers. And we've also, not listed on the slide, we have analysis, which is the A in Raft. And that helps you figure out what you're going to do after you got all your data. Boring platform information, runs on Mac, runs on Linux, runs on Windows. Easiest way right now is just to do it on Linux. You'll need to grab a few dependencies from apt-get. In Backtrack, I think you need to do one apt-get of what?
Qscintilla 2. So if you have Backtrack 5, you just need to do apt-get install Qscintilla 2.
And then download the tool, and it'll work right off the box.
Yeah, as far as Mac goes, you're going to need to pull down everything through Mac ports. Works a lot better than the internally built-in.
Yeah, and we are working on creating. It just wasn't done in time. So like an executable, standalone.app for Mac. So there won't be any need to deal with dependencies.
Windows will work, but you're going to have to do some work compiling a few things because we've got a dependency that.
Mainly LXML.
Yeah, LXML. You'll need to compile that, but it will work if you.
Easy install is your best bet there.
Yep.
So dependencies, I'm not going to list all these off, but our goal was to keep any third-party stuff we were doing, we were trying to keep it packaged. The things that we couldn't, we were trying to minimize as much as possible. There's not a lot here. Most of it's easy stuff. So it's up now on Google Code. There's the URL. We'll have the packages soon like they were talking about. You can also submit bugs when you find them. We've already found a lot, and I'm sure there are a lot more to find.
So one of the things I hope people don't do is download the tool and have something break, and then they're like, because I've done this in the past, so I'm guilty. I'll try a new tool, you know, and something breaks, and I'm like, this sucks, I'm never using it again, and the next thing you know, everybody's using it and telling you how cool it is, and you've like totally written it off. So I know I'm a hypocrite, but please don't do that, because we can fix them eventually.
Yeah, I mean, like the tool's stable now, but it's probably going to be like another week or so before it's actually in usable condition for people to get down and dirty with
for the
some
active
stuff.
testing
For the
tools.
active
You can do all the
testing.
analysis.
Yeah,
right
all the
now.
analysis stuff is there, and it's ready to rock and roll.
Import and browser all works well
Yep.
too. So if you just need to import stuff and analyze, you're in great shape. All right, so we talked about, and that's actually what we were just saying. So even if you don't need to do any further testing, this is great for grab all your stuff from all your other tools and then run whatever analysis you need to do. If you then discover that you need to hit the site a little more, use the built-in browser, look around a little bit, and then run whatever analysis you need. All the fuzzers and things, you could completely ignore that if that's what you need to do. I talked a little bit about data sources before. Here's a nice list. We've got our own formats. We've got Burp, WebScarab, Paros. It's pretty easy to write one of these, and Greg's going to show you a little bit about what the thing actually does.
So bear with me here, because this is always a challenge to get over and
On the other side.
Yep, the other way. So this is the user interface. It has a pretty decent look and feel on all the platforms. We think Mac looks the best, and we did a lot of our development on Mac, so it's pretty well tuned. Just approaching this to do like a simple task, let's go ahead and import some existing capture data.
And the reason these things, obviously we're having screen resolution problems, so it's all squished and you can't really read all the tabs, but.
There we go. So this is some capture XML. Our capture format is XML. We have a DTD that we've included. It's both in the white paper as well as in the code, so you can grab that. Pretty straightforward. We'll go through it in a little while, but go ahead and import our data. And right off the bat, this was just going out to Altero Mutual, and we were running this through a couple different proxies, doing a couple different tests, grabbing this data. So right off the bat, we're not connected to the network in any way. So all of this data that we're rendering here is being pulled from our existing capture format. So we're taking the browser, rendering everything, pulling it out of the existing data, and you right away get a generated source view of all the internal data. And you can see that we have syntax highlighting. Here, I'll zoom in. One of our complaints is always that tools don't have decent zoom in functions, and so we're like, that's the first thing we're building in, is the ability to zoom in. So even if you're just giving a presentation or you want to take screenshots for your documentation, you can have good view into your data. So this is a Scintilla for people that don't use it. They have pretty good syntax highlighting for a number of different languages.
I'm going to jump in. One of the things that we didn't talk about yet, but every time I've had to write something custom and then end up with a bunch of data, it is really nice to just have it highlighted so you can read it. Every time when I get a bunch of data from something else and it's all in a SQL file or wherever I had to do with it, it's impossible to read it by hand. This way, it's a piece of cake.
Yeah, so and we go through and we pull out of the data all of the links, so you get a nice list of links that you can take and import, copy into another tool. Any comments that have been found, none on that one. Scripts, so none in there, but you get a request and response view. You can see the request that was sent and a view of the raw response that came back. We offer the ability to add custom notes, and if you have Burp Pro and run the scanner, when you import data that was from the scanner portion, all the notes come in. So that's actually very handy. If you have to go back and do some additional research into a problem, you can see all that data right there. So we'll be going through some of these other pieces of the interface.
Double click on one of them,
so we'll go ahead and double click. And we also have a kind of a popped out view that gives you some broken down data so you don't have to try and decipher all that across the screen.
analysis.
Huh?
Just play.
Yeah, did we go back?
Yeah. Hit F, play. Is it?
No, you want Keynote.
Yeah.
Apparently I don't know how to use a Mac. Sorry, guys. All right, now analysis, it is kind of in the title, right? This is one of the main reasons we wrote Raft, is we wanted to be able to do analysis on the data, either as it's coming in, the stuff that's sitting around, that's been around for a while, that may be stale, but still has good information in it. So our concept for analysis is basically anywhere you want to do analysis, you should be able to do it. Whatever's in the tool should be analyzed at some point. Currently it's anything that's in the responses list. We are looking at ways that it'll actually do it as we fuzz the data. Just kick it off as it gets responses and things of that nature. But a lot of analysis that we do is going to be, not just on a single request response, but the whole session, right? To see how the first response differs from the last response, because there may be some vulnerability there that is exposed in that way. The analyzers are integrated with the other tools within Raft, so you can, basically it's all one tool, so we're accessing the same data sources. New analyzers are extremely easy to add. We were sitting around last night, and I think we wrote the XSS Finder analysis module in all of, 10 minutes, I think it was, that will actually identify what XSS has already been identified by burp or by the tool itself when we're running the fuzzer. It's really easy to do. We'll show you how to build one really quick if we have enough time here. And the other thing that we want to do is for the analyzers to be able to call each other. So we want to be able to chain this analysis. If you find a base64 encoded value, hey, let's decode that base64 value and then call analysis again to see what was in that. So you don't have to actually do it manually, but have the tool do it for you. All right, we want to find what everybody else is ignoring, right? This timing analysis, we've already talked a little bit about that. Image analysis, the EXIF data. Just recently, Google Images now supports looking in the EXIF information within a JPEG. It'll tell you where exactly that person is located. But we can do the same thing. It's just something that has been ignored for a long time, but may be interesting. You want to know if you're posting images that actually show your location on your public website, right? Or locations of your employees or anything like that. Could be interesting. The possibilities are really endless. If you can think about it and you can figure out what it is inside that data, you can write an analyzer to see what is there. Okay, so the demo. Which side are we on? Left?
Yeah,
or right?
I don't remember.
Okay, I'm on right. Okay, so we've got a list of responses here. I think we've only got like 20 or 30. There's one icon up here at the top that does an analysis for us. It goes really quick just because there is very few for us to analyze. When we click the analysis tab, it comes back. In this case, there's only, 26 results because there's not that many requests. The analysis modules that we've already written, the analyzers, we're detecting .NET application server errors, insecure cookies. These are kind of low-hanging fruit that we've identified already. I've got the XSS Finder in there, but we didn't identify anything yet. We'll show you a bit later how we actually do that with the fuzzer. There's the sample template in there, and that finds a whole bunch. But we've also written a couple more generic analyzers for people to use. There's a regex finder and a string finder. So both of those, if you can write a regex, you can go in and actually put in something that's interesting to you. I think in this case, we might have found, some phone numbers or something along those lines, right? Yeah, private information. But we're so big that I can't see. Yeah, so we've got a phone number that it's identified in there. And we've written a regex for that. But you can go and add that from the configuration itself of that analyzer. We know that the regex finder is in there. And we have a list of different things that the regexes that it's looking for currently. You can add them here, or you can code them up wherever you want to. Let's see. So there's more in there. If you're interested in what each of those analyzers do, go pull down the tool. Some of them are half-baked, but others of them are fully functional, and we are improving them. If you've got an idea for one and you don't feel like writing it, shoot me an email or shoot us an email, and we'll do our best to implement it because it is interesting stuff. Okay. That takes. It's really easy. I mean, when we're adding analyzers, what we do is actually scan a directory within Raft looking for Python code. And if the analyzer's there and it contains the correct functions, it'll pull it in and actually send each of the transactions to the analyzer for whatever it wants to do with it. Yeah?
Is there a way to map results to the sequences that produce them for regression testing?
Yes.
The question was, is there a way to map results for regression testing, correct?
Yeah. And we won't get into that right now, but it is fairly easy to do. Okay. Let's see.
So I think we're going to move this along. We saved all the good stuff for last, and now we're running out of time. So, so we have some implemented smart testing components. So as far as the requester goes, we have the requester and the fuzzer. They're all template based. So you can take data from multiple locations, define your template, and then run it. We also have sequence running, and we're using an actual browser object, so we have visibility into things, such as DOM fuzzing. Like those are the kinds of things we can do. And we use a templating approach to allow you to mark up and then run pre and post sequences. So just to give you an idea of what this looks like, let's go to the web fuzz. Or well, yeah, choose a request from. Did you import the?
Where's the?
Oh. Right here. Yeah. So we're going to do a little demo here of what the web fuzzer would look like. So we just used our own internal web browser to call out to this.
Yeah, so we've got a VM running that's got the OWASP
broken web apps
web apps running on it. So in this case, this is vulnerable to cross-site scripting, and we know that, so we're using it as an example. So once I've made the request with the web browser, I didn't have to go and run it through an inspection proxy because, with me, this is not an inspection proxy, but I can use the browser to actually access it and preload that information. So that'll show up within the responses, very bottom. Let's make sure that we got that request. Yep. So there's the request. We go ahead and send that over to the fuzzer. And at that point, we just have to configure the fuzzer to actually fuzz this name variable up here. We'll append the payload to the end of the URL. And we have to configure what fuzz set we want to use. Right? We don't want to use SQL injection. We want to look for cross-site scripting. Jump back over, start that attack, runs. We do have the progress bar down at the bottom. You can actually view the results, and it'll show you each one that was sent, what information was there. Right? At that point, the fuzzer's been sent. We don't have actually those results yet. It's not tied in, but we can still just click the analysis button, and we've got another set of analysis that has run. Right?
Another thing you could do in that case, we have a built-in, so on the render tab, if you just kind of keyed down on that, at some point that browser object would do an alert window. So if you wanted to do a really quick and dirty like that too, you could just thumb through, see all the results, and you get the pop-up.
Yeah, so in this case, the XSS finder has identified, hey, I saw an alert box that came back from the request, and it's successfully rendered when I actually go in and view the results. So we know that this one is, in fact, an XSS vulnerability. Now, some of these won't pop up in an alert box because we are running WebKit. If it's XSS that only executes within IE, it's not going to execute, obviously, in WebKit. So you're going to have to still comb through the data a little bit, but this has refined it to a point that I only have to view 8 results rather than 100 or 200. I mean, XSS is one of those common problems that we have to comb through so much data when it comes back from an automated tool. Okay. So that takes us back to, where are we at? Sequence fuzzer?
Yeah, so this isn't quite implemented yet, but we didn't have time to implement it before we got here. So basically the being able to tag data from multiple locations and place it in your fuzz payload for CSRF tokens and such. And I think we're going to, well, do you want to do the sequence builder demo? So we have a built-in sequence builder.
Yeah, so this puzzle piece is a sequence builder, and I'm not going to go through and demo all of it, but the basic premise is you start recording. collect your information, and there's displays for cookies and parameters. And like we said, it's not all functional yet completely, but we're going to offer some different types of sequences, sign in, sign out, fuzz, and just like a generic sequence you can do whatever you want with. Our session detection, we offer both in-session patterns and out-of-session patterns. So we kind of are approaching that problem where you have both on one page. We can start to do intelligent detection of that problem. The big thing that we're going to do is the dynamic data replacement. We're going to start any source request values and values that come back. We're going to link those together so that we automatically handle all your CSRF token problems automatically. You won't have to do anything unless there's like custom code that has to be written.
So how many people here would like to find DOM-based cross-site scripting without having to load a browser plugin or send that data to somebody else's website for analysis? Hopefully that would be everybody who would like to do that. So let's just go ahead and demo our DOM fuzzer.
We have this stored in a RAF capture format. Extremely convenient. And come back over here. And get down. And I have a couple of URLs that I know are vulnerable in various states. So let's go ahead and send those over to our DOM fuzzer. Our DOM fuzzer is extremely simplistic currently. It just has some very basic values that it tests for. And the way it works is it inserts some scripts with alerts, some character sequences, and what it does is it takes the resulting HTML that came back originally, constructs a URL with those values, and in a completely offline manner asks that to be rendered, and any scripts that are on that page would get run and include that URL value in the response. So we have a little fuzz window over here if we want to see what's going on. It sometimes doesn't show much. Yeah, it's probably on uninteresting ones. Yep, it's still going. Yeah, there's some that are actually rendering. And we should be seeing some results. So there's two ways we detect it. One, by pulling the data out of the DOM and doing pattern matching, and that kind of gives us this medium result. The other way is hooking the alert box in the browser so that we can say, we popped up an alert box and it had this number in there. So that's DOM-based cross-site scripting right there. In tool, offline, you could download data. You could take your old saved data if you can import it in here and you have all the appropriate script references and start finding these very basic DOM-based cross-site scripting.
What's the next thing?
Oh, yeah. And another very interesting thing, and it's good we're a little short on time. So one area that is completely untested and unmined, and we're starting to see these pop up because developers don't understand they're actually using this, is HTML5 storage locations. They import JStorage and they start using it and they don't understand where it's actually getting stored. So in our tool we have the ability to read any local storage files that are created because they're just SQLite, so we pull those data values in. You can go through and you can edit them. In this case we went out to html5demos.com, imported some values, modified one of the values, and when we go back to render it, we get XSS out of that. Just like that. That's data that's being sent, that's not even being sent over the web, it's coming from a client-side location. And some people say, well, how would you exploit that? Well, let's say you have an application that's storing stuff in a client-side location and one page doesn't do proper sanitization and it stores it in the database and another page is reading it out and it's not doing encoding. Bang, right there, you have some sort of cross-site scripting condition. And if you can force the user into that, maybe by forced browsing, you can get code running within the context of their website.
Let's go ahead. We'll finish it up. So basically, we're working on documentation, but obviously getting the tool working was kind of first. If you go out to our site, the Google Code page, you'll see that there's a wiki there where we started. JRock wrote some stuff about writing your own custom analyzer. And of course, we have language integration with multiple programming languages.
No, actually, we just use an XML format. So yeah, here's our DTD. So we just wanted to get it in the slides for people that are going to be pulling this down and looking at it so they get some idea. And here's kind of how it looks. Sometimes it's hard to visualize XML from a DTD, so it's very basic. request and response, those are split out separately. Any data that you can include is beneficial. There's always been a challenge like to store binary data, and it's like there's a very simple solution to that, and that's just to base64 encode it. I mean, base64 is pretty much available in any language, on any platform, and it's a well-defined format.
Past that.
Yep.
So you might be asking like what the weaknesses of Raft are right now. Obviously, there are a few. And some of these are ones we know about. So SQLite, obviously, that's what we're using to store all this data.
Yeah, somebody yesterday was asking if we could, scan 1 million websites and throw the data all in here, but SQLite's probably not going to support that. Right? We're going to have problems.
It'll croak and die a horrible death. And of course, we have bugs that we're aware of, like you have to run Raft out of the project directory.
Yeah, for some reason, Nathan didn't want to write any error handling. It was his job.
Error handling is for suckers. And of course, the web fuzzer right now has some hard-coded payloads, which are terribly unintuitive, but that's just because we needed something to work for the demo. Obviously, we're going to allow people to take their payload lists that they've been collecting for years and use those as selectable options. So we're aware of those, so please submit bug reports and feature requests. So there are some things that we have coming in the future. Obviously, we have more analysis components. That's one of the things that we're on the hook for. We're also thinking about doing an integrated scanner functionality, reporting output, and a command line interface. And what we are not working on is an inspection proxy. Just in
case anybody's wondering.
Yeah,
right?
in case you're wondering. So, I guess that's it. So, if anybody has any questions.
All right. Yeah. If you don't want to ask it now, feel free to come up and we'll talk with you after.
There's one more important slide, Nathan.
Yeah.
Yes, feedback forms.
Yeah,
fill out your feedback forms. That's important because if you sat in here this whole time, we think you probably were at least a little bit interested. So hopefully the people that left didn't hear about the feedback forms. So give us good feedback and we'll be back with new and crazy stuff.
Thanks, guys.
Thanks.